Geomorphology. See guys, first one is continental drift theory. Here, Wegener discusses about forces. Remember, they won't ask question on forces because it is wrong. Okay, the forces assumed by Wegener is not correct. So, question will not be about the forces. I'll just give you the forces. One is buoyancy force. Tidal force, gravitational differential force, polar fleeing force. So this is not required, okay, but theory is important. In the theory, the first point, initially all the states were, or all the continents were together at which pole? South pole. So initially all the continents were together at South pole. That is called Pangea. Pan is super, Gea is continent. Super continent surrounded by super ocean. Here I want you to remember South pole. Okay, it was closer to South pole. Later it split into two. What are the two aspects that it splits into? Laurasia and Gondwana land. Okay, in exam they can give you Laurasia, or they can also call it as Angara land. Laurasia or Angara land. Another one is Gondwana land. These two are or were separated by Tethys Sea. Okay, so here when we say Laurasia, now what is the question? Laurasia, when they say, you should remember that it included North America and Eurasia. In Asia, there was no India. Okay, Laurasia included North America and Eurasia except India. Okay, Gondwana land included South America, Africa, India, Australia, Antarctica. Yes, 5 continents were there. This was last year prelims question. Okay, they said 6. Gondwana land included 6, but it had 5. So which are the 5 you see? South America, Africa, India, Australia, Antarctica. They are part of which one? Gondwana land. Yes, from Laurasia, North America drifted away from Eurasia. You see, North America drifted away from Eurasia to form North Atlantic Ocean. Okay, North Atlantic Ocean. So please understand, Atlantic Ocean is a divergent boundary. What is Atlantic Ocean? Divergent boundary. Next, South America got separated from Africa and Antarctica to form which ocean? South Atlantic Ocean. So please understand, North Atlantic, South Atlantic. That means Atlantic Ocean is formed due to which boundary? Divergent boundary. Now, Africa, India, Australia and Antarctica, all these got separated to form Indian Ocean. Okay, so Indian Ocean is also divergent boundary. Okay, so Atlantic Ocean is a divergent boundary, Indian Ocean is a divergent boundary. What about the remaining ocean? The remaining ocean is basically Pacific Ocean. Can I say remaining is formed because of convergence from all the sides? Yes. So Pacific Ocean is what type of boundary? Convergent boundary. This is the reason Pacific Ocean has Pacific Ring of Fire. Have you heard? Pacific Ring of Fire. Why is Pacific Ring of Fire present? Because of what? Convergent boundary. So there you see Atlantic Ocean, Indian Ocean is mostly divergent boundary. Pacific Ocean, on the other hand, is convergent boundary. Okay. Next. Evidences questions are more, guys. Last time also there was question on evidence. Evidences, first one. Jigsaw fit of continents. What is jigsaw fit? All the continents can be brought together as one. Especially jigsaw fit of continents on either side of which ocean? Atlantic Ocean. Second, fossil evidences. So, just one name is enough. Mesosaurus, freshwater reptile, is in South America and Africa. Fine. Mesosaurus, freshwater reptile, is in South America and Africa. Third, is very important. Mountains on either side of Atlantic Ocean is formed at the same time with same composition. Example, Appalachian in North America and Atlas Mountains in Africa. They are formed at the same time. Please understand, remember this. On either side of which ocean? Atlantic Ocean. Yes. Gold deposits are present in upper and lower Guyana region. This is in South America and Africa. Very important. This was last year question. Gold deposits are present. Yes. Glacial till means the deposits from the glacier. Glacial till is present in Gondwana land. Means how many will come? These two, 4th and 5th was prelims questions. Okay, data of 4th and 5th were asked. Next is glacial marks. We say glacial striations or marks. They're actually present near equator. Bituminous coal is present in mid latitudes. These 7 points are evidences. Once NCERT 11th standard, read evidences carefully, even before exam. Okay, 11th standard, language wise, see what is there in the NCERT clearly once. Okay, next. Yes. Glacial striations means marks. So if I drag this, some marks will come. Same way when glaciers move, some marks will come. So glacial marks normally must be present near poles, but it is present near equator. So glacial marks present near equator. Okay. And bituminous coal must be near equator because it is formed from evergreen forest, but it is found in mid latitudes. Okay. So shall I move? Evidences. Now, convection current theory. See, don't remember everything. Okay, this is for prelims. So whatever I'm trying to tell, only that particular part you remember. Evidences, theory. Those two are important in the previous one. Now in this, what is lithosphere? Multiple times they have asked. What is the actual meaning of lithosphere? Means which layers are included in lithosphere? You write lithosphere, crust and upper solid mantle. 3 times in prelims they have asked this question. What is lithosphere? Crust plus upper solid mantle. Hyphen 100 kilometers. Okay, 100 kilometers. And below this there is a semi-solid layer. You can write asthenosphere, semi-solid or viscous layer. These 2 words are important. Next, in this layer we will have huge quantities of radioactive minerals. Huge quantities of radioactive minerals. See this? Radioactive minerals release the heat. Heat will melt it. As it melts, molten magma rises. Okay? Molten magma rises. This rising of molten magma is called as mantle plume. Yes. You write this word, mantle plume is observed in asthenosphere. You wrote what is lithosphere, what is asthenosphere, then third word, mantle plume is observed in asthenosphere because of radioactive minerals. Radioactive minerals, underline the word. Okay, radioactive minerals and cooling of the earth. So these 2 words are used in NCERT. Cooling of the earth. So you will have radioactive minerals everywhere and this particular one is called convection current. So you write below, convection current is observed in asthenosphere and it is due to radioactive minerals and it is responsible for endogenetic process. Get this? So what is the main reason for endogenetic? convection current in asthenosphere. So what is endogenetic? Wherever lava rises and goes out, it leads to divergence. Wherever they move towards each other, it leads to convergence. Next case is the new topic on which questions are increasing is about geomagnetism. See guys, if I have to make a magnet, I should have iron particles. To this iron particles, if battery is connected, charged particles will go through this. And the charged particles, when they touch the iron, it will become electromagnet. And it will have its own field called as electromagnetic field. Same way, if we consider inner core is made up of nickel and iron, and around it you will have outer core. Outer core is mostly in liquid form. The interaction between inner core and outer core has led to what we call as geomagnetic field. Okay, so I'll tell the words, please write down. Geomagnetic field hyphen. The interaction between inner core and outer core leads to geomagnetic field. Next point, most of the planets has magnetic field. The characteristics required for magnetic field are first one, the planet must be rotating faster, very important. The planet must be rotating faster. Remember, if the planet is not rotating faster, there is no magnetic field. Rotating faster. Second, there must be liquid layer inside. Underline liquid layer. There must be liquid layer inside. Third, there must be circulation inside the liquid layer. Fourth, there must be conduction between liquid layer and other layers. Okay. Benefits. What are the benefits of geomagnetic field? Do you recollect Earth lost primordial atmosphere to solar wind? Yes, you write below. It protects Earth's atmosphere from solar wind. Second point, It protects satellites and other communications. Next, it will not allow harmful particles from sun and other stars from reaching the earth. Next point, interaction between Earth's magnetic field and solar wind leads to aurora borealis. Have you heard? Aurora borealis and aurora australis. It is also called northern lights and southern lights. Underline the two words there. Interaction between which two? Solar wind and Earth's magnetic field. Please understand, it is not between ionosphere. Ionosphere is not important. What is important? Like, Earth's magnetic field is important. Guys, can you tell me where do you have more geomagnetic field? Can I say more geomagnetic field will be near the poles? So if more geomagnetic field is near the poles, like, we normally observe what do you call it as auroras mostly in the poles. But recently in Ladakh, we have kept a telescope. And from that telescope, we have identified that auroras are present near equator also. That was the reason question was asked in exam. Okay. So you write there, auroras are present mostly near poles because there is high density of magnetic field. But in recent years it is found near equator as well. Done? Okay. Last. See here. If we take Earth, 90 degree north, 90 degrees south. This is called geographic north, geographic south. Geomagnetic north, magnetic south. Where it goes out is called as geomagnetic north. Where it comes inside is called as what? Geomagnetic south. Please see here, geographic north and south are different from geomagnetic north and south. Geographic north and south are fixed, latitudes are fixed. What is changing? Geomagnetic north and south is not constant. It keeps changing. These two words are important, you write? Geographic north and south are different from geomagnetic north and south. Magnetic north and south. Next point. Geographic north and south. Geographic north and south is fixed. Whereas geomagnetic north and south, magnetic north and south shifts. Are you getting the point? Yes. You see here, if this is Earth, this is geomagnetic field. See, where the lines are present, we call it as geomagnetic field. Where it has extended beyond, magnetosphere. What is it called? Magnetosphere. Can I say magnetosphere is extended? Yes. What is the role of magnetosphere? It will hold harmful particles. It doesn't allow harmful particles to come. Okay? It will hold harmful particles. That is called Van Allen belts. Okay? Van Allen belt is harmful particles held by Earth's magnetosphere. And there will be two Van Allen belts, inner Van Allen belt and outer Van Allen belt. Okay, two things is, one is what? Auroras are due to interaction between solar wind and geomagnetic field. Second, like magnetosphere holds harmful particles called as Van Allen belts. Fine. Next, shall I? Sea floor spreading. Seafloor spreading was studied with respect to Atlantic Ocean. What did they observe? They observed at the center of Atlantic Ocean, there will be mid-Atlantic ridges. Exactly at the center, you will have mid-Atlantic ridges. And these are active. They are active. These mid-Atlantic ridges are in S shape. Okay, they are present in Arctic to Antarctic almost, and these ridges extend into Indian Ocean and Pacific Ocean also. Which one? Ridges from Atlantic, they enter into Indian Ocean also, Pacific Ocean also. Okay, so if I call this as South America and Africa, at the bottom have sediments like this. Sediment thickness decreases from continent to ridge. The thickness of the sediments decreases from continent till the ridge. This was done 50 million years ago, 100 million years ago, 150 million years ago, 50 million years ago, what is the meaning of this? Age of oceanic crust decreases from continent till the ridge. Okay, age decreases from continent till ridge. Okay, 4 points will come in seafloor spreading. What is the first point? At the center of Atlantic Ocean, we have mid-Atlantic ridges. Okay. Second point is sediment thickness decreases from continent till the ridge. Third point is age decreases from continent till the ridge. And then if we look at iron particles alignment, it is alternatively arranged indicating magnetic anomaly. Magnetic anomaly means, you see, iron particles, they will arrange according to the Earth's magnetic field. So if entire crust is formed at the same time, all of them will be arranged in this direction. But if this is formed at a different time and this is formed at a different time, if one is in this direction, another one will be in this direction. So opposite direction alignment is called as magnetic anomaly. Okay, just remember the word magnetic anomaly. What are the 4 words of seafloor spreading? What are the 4 points? Exactly at the center, what do you have? Mid-Atlantic ridge. Are they active or passive? Active. Second, sedimentary thickness decreases from where to where? Continent to the ridge. Third, age decreases from where to where? Continent till the ridge. Fourth, there will be magnetic anomaly. So just you write below, from the above, it is understood that new crust is formed near the ridge. New crust is formed near the ridge. Second, continent is older. So you can write continent can be older than oceanic crust. Can be older than oceanic crust. Plate tectonics. Composition size. Yes, based on composition, it is divided into continent and ocean. Continent is made up of silica and aluminium, and it is 35 kilometer thick. Okay, 35 kilometer thick. Ocean is made up of silica and magnesium. It is 5 kilometer thick. Okay, if we go by size of the plate, major, minor plates, there are 7 major plates. North American plate, South American plate, Africa plate, Indo-Australia plate, Pacific plate, Eurasia plate, Antarctic plate. Some of the minor plates are Arabian plate, Philippines plate, Cocos plate, Nazca plate. There are many. 7 major you try to remember. This continent and ocean. Can we say ocean is denser compared to continent? Okay, ocean is denser compared to continent. Next, we'll talk about tectonics. before I talk about tectonics, guys, if a lava comes and solidifies in cone shape, okay, if a lava comes and solidifies in cone shape, it is normally called volcanic mountain. Okay, solidifies in cone shape, it is called volcanic mountain. If it is in the form of anticline and syncline, then it is called as fold mountain. Block mountain. Steep slopes will be block mountain, anticline syncline will be fold mountain, and cone shape is volcanic mountain. Now, if I take the fold mountain, if at all height increases, it will be called as young fold mountains. If height decreases, old fold mountains. Yes. See, normally what happens if height is not increasing, exogenetic forces will reduce it. So height keeps on reducing. Any old fold mountains, height keeps on decreasing. Height will never be constant. If it is increasing, pressure is from inside. If it is decreasing, then it is old fold. Okay, now guys, based on this, tectonic movement is divided into three parts. Convergent boundary. It is also called as destructive boundary. Convergent boundary or destructive boundary. Okay, why are they called as destructive boundary? They are called destructive boundary because melting of magma occurs. Okay, so in this, everyone, there are three types. First one, continent ocean convergence. Continent ocean convergence. See here guys, wherever the convergence occur, deepest part will be there, called as trenches. Remember, trench is a feature of convergent boundary. Okay, trench is not observed in divergent boundaries. First. Second, wherever it goes inside, melting occurs. This particular aspect is called as Benioff zone. Benioff zone, very important. Next, this one will start rising above. When it melts, it starts rising above. And when it comes out, it looks volcanic. So this will be volcanic mountains. Then here, whatever sediments are there, those sediments will be compressed. And as they are compressed, it will be called as fold mountains. Okay. So, wherever continent ocean convergence are there, what are the features you observe? You observe volcanic mountains. You observe fold mountains. Along with it, there will be earthquakes. And as trenches are present, anywhere trenches are associated with tsunami. Tsunamis are also present. Means already they have asked about tsunami. So again there is possibility of a question on tsunami. Okay. Convergent boundaries, especially trenches, not trenches, trenches leads to tsunami. Okay. Okay. Now, this example for this is Rocky and Andes Mountains. Rocky Mountains in North America, Andes Mountains in South America. Ocean-ocean convergence. This is subduction or Benioff. What is this part called as, guys? Trench. Whenever it comes from here, it would lead to islands and ridges. Are you getting the point? So, what all are formed due to this, guys? There will be islands, there will be ridges, there will be trenches, and if trenches are there, what will be there? Tsunami will be there, and there are earthquakes. These are all features of ocean-ocean convergence. Example, Japan, Philippines. Okay. Next. Continent-continent convergence. Is wherever you have continent-continent convergence, normally trenches won't be there. You will have fold mountains. Fold mountains and earthquakes are common in very few areas. Volcanoes will be there, not everywhere. Very few areas, volcanoes will also be there. Himalayas are examples. Next, shall I move? Last year tsunami is due to what? Trenches. Trenches near Japan, right? Curated trench and all we call. Then we say divergent boundary. Divergent boundary. First one, continent-continent divergence. I told you three types of mountains: volcanic mountain, fold mountain, block mountain. Volcanic mountain is a phenomena of both convergent and divergent. But when it comes to fold mountains, it is phenomena of only convergent. Block mountains are phenomena of only divergent. Okay. So, continent-continent divergence, you see, if we have a continent, and below the continent, wherever magma rises. Okay, so wherever magma rises in that particular part, there will be upwarping like this. And as you have upwarping, cracks develop. Through the cracks, volcanoes will come. I just want you to write the names. Diagrams are not required, only names, okay? Continent divergence. First stage. You write first stage. First stage. This area has come up. You write it as upwarping. Upwarping. Second, you write cracks. Cracks. Third, you write volcanoes. Fine. Next. After this, again when there is divergence, some part of the blocks will go downward. When they go downward, here water gets accumulated. If water gets accumulated, it is called as rift valley. Okay, if water gets accumulated, it is called as rift valley. And this particular part is known as block mountains. Okay, block mountains is a concept of which boundary? Divergent boundary. Okay, block mountains are divergent boundary. Examples are very, very important. Vosges Mountains, Black Forest, Vosges Mountains, Black Forest, Western Ghats. Vosges and Black Forest in Europe, 2 years back prelims question, Europe, Western Ghats in India. They are typical example of, like, block mountains. And Rift Valley, there is something called as East African Rift Valley. Okay, East African Rift Valley. Rhine Rift Valley. East African Rift Valley, Rhine Rift Valley. Rhine is in between Vosges and Black Forest. Is wherever it rises, it is basically called as linear sea. Okay. Example of linear sea is Red Sea. This year, there was a volcanic eruption after 12,000 years in Ethiopia. That was divergent boundary. Okay. After 12,000 years, there is a volcanic eruption which is divergent boundary. Can I move? And guys, finally, you will have mid-Atlantic ridges. Mid-Atlantic ridges. And Atlantic Ocean. Mid-Atlantic ridges and Atlantic Ocean. So this is ocean-ocean divergence. Okay, because by the time everything moves, it becomes ocean-ocean, right? So just add one line. Ocean-ocean divergence, ocean-ocean divergence leads to new crust, and mid-oceanic ridges. Next one, transform boundary. So when both are moving parallel to each other, there will be earthquakes. These earthquakes are called as transform boundary. Myanmar is an example. Clear? Okay. Now, you make a table. I want you to see this in Atlas later. Continent, mountain, type of mountain. Okay. North America, Rocky Mountain, Appalachian Mountain. Rocky is what type of mountain? Fold, that to young fold mountain and volcanic. Appalachian is old fold mountain. Yes, Appalachian. Old fold or residual. South America, Andes Mountains, Young-fold mountains and volcanic. Okay, North America, South America. Chalemo. Africa. On top, Atlas Mountains are there. Below, Drakensberg Mountains are there. In between, Mount Kilimanjaro is there. Atlas, Drakensberg, Kilimanjaro. Atlas is old fold mountains. Drakensberg is old fold mountains. Kilimanjaro is volcanic mountain. Europe, if you take, in Norway, Sweden region, Scandinavia or Scandinavian mountains will be there, which are mostly old fold mountains. There is Alps mountains. Alps mountains is young fold mountains. Vosges and Black Forest is there. Both are block mountains. Vosges, Black Forest will have block mountains. Yes. Caucasus Mountains are there. In between Black Sea and Caspian Sea. It is young fold mountain. Ural mountains are present in Russia, which is old fold mountains. Fine. Next. What do you have? Before we come to Asia, Australia, Great Dividing Range. Old fold mountain. New Zealand, Southern Alps, Engfold Mountains. Turkey. Taurus. Engfold Mountains. Iran. Zagros and Elbrus. Engfold Mountains. South Asia. Hindu Kush. Sulaiman. Himalayas. Kunlun Shan. Hindu Kush, Sulaiman, Himalayas, Kunlun Shan. Engfold Mountains. Southeast Asia. Arakan Yoma. Peguyoma. Engfold Mountains. Arakan Yoma, Peguyoma. Engfold Mountains. Okay. They are asking match the following. You should have clarity of this. CAPF exam, they have asked about trenches in Pacific Ocean. NCERT has a box of trenches present in Pacific Ocean. The trenches you try to remember once. Okay, only Pacific Ocean. If you read everything, it's not wrong, but giving. Okay. Guess these are all the theory part we have. So then we have rocks and all. We'll take break.